Hello everyone, my name is Rohit Kumar Thakur and I am from Sikkim Government College, Namchi. My bearing roll number is 21NS0173 from the third semester BSc Physics Honours. My topic is depositions of the technique of chemical vapor deposition or CVD. Introduction. The chemical vapor deposition is a chemical process used to produce a higher purity, higher preference at the solid metals. It is a typical CVD process that substrate it is exposed to or more volatile precursor which reacts and decompose on the substrate surface to produce the desired deposition. During this process, the volatile byproducts are also produced, which are removed by gas flowing through the reaction chamber. Let's understand what is CVD or chemical vapor deposition. Chemical vapor deposition is a process whereby a solid metal is deposited from a vapor by chemical reaction occurring on or it is a vacant or a normal heat substrate surface. The solid metal is obtained as a coating, powder, or as a single crystal. By, by varying the experimental condition, the substrate metals, the substrate temperature, and the compositions of the reaction gas mixtures, the total pressure, gas flow, etc., maintaining with the different properties can be grown. CVD is an example from the solid vapor reaction. Now, next steps involved in the chemical vapor depositions. There are the 7 steps that are involved. Number 1 is a chemical transport of the reactant by force the conversions to deposit the reaction, transport of the reactant by diffusing from the main gases streams to substrate the surface, absorption of the reactant in the welfare of the substrates, chemical decompositions, and the other surface reaction take place. And the other 3 are written below. You can read it out. And another steps are there are 2 types of CVD. CVD are classified into 2 basic operating pressures: atmospheric pressure CVD and the lower pressure CVD. In lower pressure CVD, there are three are also divided into 3 parts: plasma enhanced CVD, photochemical vapor deposition, and also last is thermal CVD. We will first understand the atmospheric pressure CVD. Atmospheric CVD are involved in 2 cases: higher temperature. This process is used to deposit the silicon and compound films or the higher metalloid coating like titanium carbide and the titanium nitride. In case 2, the lower temperature, mainly insulator films layers such as silicon dioxide need to be deposited at a lower temperature for the effect deposition. And the next point, let's continue. The aluminum oxide files are deposited by the method from the aluminum tetrachloride argons oxygens gas mixtures at the temperature ranging from 800 to 1000 degrees Celsius. The films have the lower chlorides containing which continue to decrease when the increase in the temperature. Elastic of the film growth rates on the substrate involves that the growth take place only by diffusing from 800 to 950 degrees Celsius and also by gas phases reaction at the 1000 degrees Celsius. Next, this is actually chamber of an AVCV, and this is wafer. You can see the diagram out here. You may be clear by this process. Next one is limitation of atmospheric pressure chemical vapor deposition. Film's thickness uniform cannot be maintained. Large number of pinhole deforms can be occur. Wafer throughput is low due to the lower deposition rate, and deposition get continue very easily contaminated very easily since it take place at the atmospheric pressure. Maintaining the cytochemical is extremely difficult. Maintaining the psychochemicals is extremely difficult. And next point is lower pressure CV. The decomposition of the silicon carbide thick film is formed use a lower pressure DVC hydrogen reaction system. The silicon carbide film depositions are at the three different temperature has a three different product at 123 Kelvin, uh, amorphous at 1073 Kelvin, microcrystals 1173 peripherally. And next is that is continued. These techniques are primitive, either the horizontal or the vertical loading of an warfare into a frequency and the accommodates of the large number of warfare for the process with the process of the result in the decomposition of the compound actually pure or uniformly. However, the techniques are required higher temperature and the deposition rates are very low. In next point we'll see, and this is the third point of the lower temperature plasma enhancing CVD. Plasma enhancing chemical vapor deposition is a process used to deposit the thin films from the gaseous state to a solid state on a substrate. The chemical reactions are involved in the process which occur after creating a plasma of the reaction gases. The plasma is generally created by RF, AC frequency or DC charge due to electrodes that space the between which are filled by the reaction gas. This the helping hand of the plasma help in the increase in the film quality at the lower temperature and the pressure. And this is the third one, the photochemical vapor pressure. Aluminum thin films are deposited via via photochemical vapor pressure deposition at the crystal layer at titanium oxide and petroleum used in dimethyl aluminum hydride. Deposition deposition is carried out at low gas pressure to introduce a surface reaction based on the absorption and subsequently decomposition of the absorption of these three layer. Titanium is the effective as the crystal, like the aluminum files are thinly deposit over a lower substrate temperature of 60 degrees Celsius with the growth at 0.5 nanometers. The UV light are generated by the lamp deuterium lamp help to increase the growth rate. On the other hand, aluminum could be deposited to the titanium oxide TiO layer only used under the irritation at the substrate temperature of 120 degrees Celsius. It takes us several minutes to cover the titanium oxide surface with the aluminum. Here the next point is UV ray light is inhibited the all the growth of the surface, whereas the films are deposited to them. The X-ray, the photoelectron spectro, spectroscopy show the formation of the photolytic productions of the absorptions acting preserved as the center that enhancing the further aluminum growth. And next point, thermal CVD. In thermal CVD process, temperature as the highest as 200 degree 2000 degrees Celsius is needed to deposit the compound. There are two type of basic type of reaction in thermal CVD. The hot wall reaction, and number two is cold wall reaction. In hot wall reaction, the reaction is an isothermic surface into which the substrate are placed. Since the whole chamber is heated, the temperature control can be achieved by designing the furnace. And next point, a disadvantage of the hot wall construction is a deposition occur only on the wall of the chamber as well as on the substances. As the sequently the hot walls reaction must be frequently cleared in order to reduce the contamination of the substances. When we apply this, the contaminated in the air or in atmosphere get are being attached to the metals. So that's why it is used. In a cold wall reaction, only the substances are heated. Similarly, there are the 3 points as follow. You can see here the deposition is also one of the substrate in the cold wall reaction, and therefore the contamination of the particle is reduced conditionally. However, the hot wall reaction has the higher throughput since the designs can be easily accommodated configuration. And next point, let's look. Advantage. What are the advantages of the CVD? CVD films are generally quiet and conformal, that is, ability of film to uniformly coat the technography or complex subsequently. And there are the four other points, and I'll read it out. The higher purity can be obtained, the higher design are nearly 100% of the thermic value. The economically in the productions, or since many parts can be coated at the same time. In next, let's look disadvantage of this process. The chemicals and the safety hazards are used casually by the using of the toxic, corrosive, and the flammable and the precursors, explosive precursors. Therefore, the extra steps has been taken in the handling of the precursors and its treatment of the reactant exons. The higher deposition temperature are the often usable to the structures already published on the subscript over more than 600 degrees Celsius. When 600 degrees Celsius is there, then this process is used. It is led to the decrease in the flaming of deposition of the metals, which different thermic expressions of coefficient which can be mathematically enabled to decompose the flame. What are these applications? Containing the contemplating for the various of applications such as varying the resistance, corrosive resistance, higher temperature pre-production, the semiconductor and the related device involved in the circuits sensor and the optoelectric device, the fiber opticals for the telecoms and used in the microelectronics industry to make the film service and dielectric conductor etc. And thank you. This was my short presentation on the CVD. Thank you.